Okay, now here's how we do an integrated rate law problem. So this is the type of data you're going to see: concentration and time. So you need your TI-84, go into second plus, which is your memory, clear all lists to make sure that your lists are empty. Okay? Then go into stat and edit so you can get into your lists. Okay? Since time is going to be your X on all graphs, put it in list 1 and put your concentration in list 2. So I have 0, 50, 100, 200, 300, and 400. Okay, list 2, enter your concentrations. So I have 0.1. I'm not going to put the 00 because the calculator would cut them off. 0.0707, 0.05, 0.025, 0.0125, 0.00625. Okay, so there's concentration. Now we need natural log of concentration. So go up to the tippy top of L3 and do ln, natural log, of list 2. And it'll do a batch transformation for the whole list. Now go into list 4 and do the reciprocal. So second function, L2, and we need the reciprocal, so to the -1 power. Okay, so now remember, in order to determine the rate law, we need to check graphs, find out which is the line. So we're going to do concentration versus time. We're going to do natural log of concentration versus time. And we're going to do reciprocal of concentration versus time to see which one gives us a straight line. So go into our stat plot, turn stat plot 1 on. We want to see a scatter plot. We want list 1 and list 2. Okay, so if we hit graph, we can look at it. We should always check and see if we have something stored. We do not, that's good. And go back to the graph. When we can't see stuff, we go zoom 9. And there we go. Not looking very straight, but we want to do a linear regression. So go to stat, go to calc, and number 4 here is our linear regression. And we need to tell it that our X is in list 1 and our Y is in list 2. Leave frequency blank. If we want to store the equation, we have to tell it vars, y vars, function, and then y1, and then calculate. And since our diagnostics are on, we have an R of 0.94. And when we see our graph, we see that that data does not fit a straight line very well. So R was negative 0.94. So we want to check the others. Really, all you have to do is look for that R closest to 1. You don't actually need to see the graph. It's just nice to. So we want to clear out our Y1. We want to go into our stat plot, change it to using list 3. And then we want to do our stat calc linear regression. And leave our X list as L1, and we change our Y list to L3. We want to store it, so vars, Y vars, function, Y equals 1, and we calculate. And this time, we've got an R of 0.99999. So when we look at this graph, it's going to show us our plot. And if we can't see it, zoom 9. Shows us our data and our line going right through it. So this one kind of went like this. This one looks great. R was 0.999, but we want to check the third one just in case. So we want to clear our Y. We want to go into our stat plot. Change it now to use list 4, the reciprocal. All right, let me try to pause this here. Okay, picking up where we were. Second 4 to get our list 4. And we've got our plot ready. But we want to go into stat calc. Go down to do our linear regression. Tell it to pull our X from list 1, our Y from list 4. Store our equation in vars, Y vars, function, Y equals 1, and calculate. Now I'm pretty sure we can't top the 0.999 that we got before, and we can't. And when we graph it, again, zoom 9. That did not zoom 9. Let's look at our graph again and try to zoom 9. There we go. We can see we do not have a good fit. So that means our notes have disappeared on us. Very interesting. Okay. Well, it was, oh, there they go. It was this one, natural log. So this is first order. All right. I'm going to switch to a different page of notes, see if we can't find this stuff. So, there we go. Okay. So since we found out it was first order, we need to go back up here and find the first order equation. Natural log of the concentration equals negative kT plus the natural log of concentration, and that means at time 0 or initial concentration. So come over here and natural log of here's the concentration at this time. See the second line in the data? And then this is the concentration at time 0. Plug those in. It's algebra to solve for K. And then the concentration at 600 seconds. Here, you would plug in the time, find the concentration at that time, and it's again just algebra. At what time is the concentration equal to 0.15? Well, in this one, that T is your unknown. So again, once you find the order, you can use the equation, and then it's just some algebra to solve for anything else.